Okay, so now we're going to talk about the differences between populations and samples. In other words, we're going to start getting into the guts or the meat of the course, some visceral type of information. Now, I just want to remind you, from what we spoke of with the other videos, that there are places in here where I'm going to be pausing and looking for an answer. You hit the pause button on the video, fill in the answer, and then hit play back up again. Okay, that's the way we do these things. All right, now populations and samples. What are the differences, and how do we use these so that we have a good understanding of exactly what we're talking about? Okay, think about regular mathematics in the term variable. Think about what statistics is all about, what we just discussed, and give me a guess as to what you think a variable is. A variable is able to vary. It's able to change because the word vary means to change. It's something that can change. It is not something that stays the same, okay? Most research with statistics we're talking about begins with a general question about the relationship between two variables for a specific group of individuals. So, for example, if we took the question we did in the last video about the number of hours sleep, we might relate that to how successful you are in school. Those would be two things that would vary: hours of sleep and success in school. A variable is a characteristic or condition that changes or has different values for different individuals. Okay? Now, if you think of some things that change: height, weight, gender, personality, temperature, time of day, size of a room, what else do you think are some things that can change? Things that are variable. What about favorite music? Favorite color? Favorite rock band? What about speed, running time, how fast you drive? All of those things are variables. Now, a population is a little bit different. In statistics, a population is the pool of individuals from which a statistical sample is drawn for a study. Thus, any selection of individuals grouped together by a common feature can be said to be a population. If you're a note taker, you may want to write that down. Okay, so you could pause the videotape and copy it. So here's the difference. This is a great diagram, all right? The population is all the people we're talking about. The sample are the ones we pull out of the population, and then we get our data from that sample. I mean, it doesn't make sense to poll everybody or to test everybody in the population. Think about when someone's running for president and they come up with all of these statistical analysis and these polls and so on and so forth. Do you think they get on the phone and call every single person in the United States of America and say, who are you going to vote for? No. They go through and they get a cluster of those people. Some of those people, cluster not in the statistical sense of the word, but they get a grouping of those people, a random grouping that should represent the population, and then they get the statistics from that small sample of people. Now, we just kind of said what a sample is. Let's have you guess in terms of a definition. Put it in your own words. It's a little tricky. A sample is a group of elements that's chosen from the population. So no member of a sample can ever have not been a member of the general population. So for instance, just for argument's sake, if you had a population of dogs and then in your sample you had a Maine Coon cat, that could never happen because a Maine Coon cat would not have been in the population. Every member of the sample would have to be a type of dog. Okay? In the short clip of Moneyball we watched, what would be the population and what would be the sample? The population would be all of the baseball players. What would be the sample? The 51 players in the report, the ones he thought that he could find value in. Sampling is a process used in statistical analysis in which a predetermined number of observations are taken from a larger population. And that's the diagram we showed you before. that the sample was always smaller than the population. That's a key point to remember here. The sample is a subset of or a smaller part of the population. In other words, it's a small enough piece that we can manage it and work with it because we don't have the resources to get everybody in the population. So another good chart that shows you what you got going on here. The population is at the head of this. It's all of the individuals that could be of interest. Then you select the sample from the population. They must come from the population. I can't stress that enough. The sample then, it's the individuals that are selected to participate in the research study. These are the only ones who are going to get questions. And then the results from the sample are generalized to the population. Okay, now there can be lots of places for breakdown here, and we'll talk about that a little bit later on. Let's apply this diagram to the relationships of a specific situation. Let's see who is who with political polling. Now the population, who do you think they would be? All the people who are eligible to vote in the country. The sample, that would be the ones that they actually ask who you would vote for. That sample is then selected to participate in the research study, and then the results are generalized. And that's where they go on the news and they say, in a Quinnipiac poll today, or in a Washington Post poll, or a New York Times poll, or an LA Times poll, it says such and such a candidate is leading another candidate. So they're not sampling every person in the voting block. They're only sampling those pulled out to be part of the sample. Okay, let's apply this diagram of the relationships to a specific situation. This time, let's see who is who with insurance rates. The population, and let's do this for car insurance, okay? The population, all the drivers in the country. They're all supposed to have car insurance. The sample is selected from the population. In other words, they choose some of them to look at. They do not look at the driving habits of every single person in the United States of America. I don't think they have enough people hired to do that. Then they get the results from that sample, the people who were selected to participate in the survey, and then they generalize it to the entire population, and that in turn lets them set insurance rates. Okay, data. Data is nothing more than measurements, observations. A data set is, a datum is. A data set is, statistical data sets are collection of data maintained in an organized form. The basis of any statistical analysis has to start with the collection of data, which is then analyzed using statistical tools. Okay, yeah, you got to begin with data. If you don't have data, what can you look at? In the video of Moneyball, that was, the data was all the performance of those players, and then a report was handed in. Those were the statistics. A datum itself can be referred to as a single piece of information or the starting point of any work, okay? And as I mentioned before, if you're copying this down and you're taking notes and that's the kind of student you are and you like to learn that way, that's fantastic. Just pause the video and copy it down. All right, so far what we've done is we've talked about statistics, we've talked about populations, we've talked about samples. Now I want to introduce two new words, parameter and statistic, and we'll give a definition to statistics. A parameter is derived from populations of measurements of individuals in a population. Well, I need to go back a one. Sorry about that. Parameter is derived from the measurements of individuals in a population. So if you tested everybody in a population, that's not called a statistic, that's called a parameter. A statistic is derived from the measurements of the individuals in a sample. So going back to driving the car, if they actually did look at the statistics if they actually did look at the data of every single person who drove a car in the United States of America, that's not a statistic, that's a parameter. But if they just pull out a sample and then look at the driving habits of the sample and then broaden that to the entire population, that becomes a statistic, okay? So this diagram again shows the population in the sample, but I added a little bit to it this time. Parameters come from populations. Statistics come from samples. And a little mnemonic device here, PPSS, parameters, populations, statistics, samples. Okay? We'll pause this video at this point in time, and we'll pick up at this point a little later on.